In this video, we will be looking at the three primary trigonometric ratios. So these ratios only apply in a right triangle. And before we get into the ratios, we have to look at some terminology and some labeling conventions. First of all, this letter theta is used for an unknown angle. It kind of looks like a zero with a line through it, but it's just another type of variable. And we can label all three sides in a triangle as opposite, adjacent, and hypotenuse, and they all depend on what we use as our reference angle. And something that is super important to know is that you can never use the 90-degree angle in your right triangle as the reference angle. So for this triangle on the left, let's say the angle on the bottom left is my reference angle. First of all, we know what the hypotenuse is. That should be the first thing you label because that will never change. The hypotenuse is the longest side, and it's the side that is directly across from the right angle. So this right here is your hypotenuse. Now, using that theta as my reference, if I draw a line straight across, the side that I hit is the opposite side. And then the leftover side is adjacent, and adjacent just means beside. So this side is beside theta, but it can't be the hypotenuse because the hypotenuse is always the longest side. So let's try again using the top right angle as our reference. The hypotenuse is still this long side, and it's also the side that is across from the right angle. Now, from my theta, if I draw a line across, this is now my opposite to theta, and then this is my adjacent because it is beside theta. And now using these three sides, we can create the three primary trigonometric ratios. And those three ratios are sine, cosine, and tangent. And if you look at your calculator, you will see those three buttons. And these trig ratios just give you a ratio of two different sides. So sine is the ratio of the opposite side to the hypotenuse. So we can remember it as SOH, S-O-H. Sine is opposite over hypotenuse. And then cosine is the adjacent side to the hypotenuse. And we can remember that as ka. Cosine is the adjacent over the hypotenuse. So all of these will be written as fractions. And then finally, tangent is opposite side to the adjacent side. So we can remember that as TOA. Tan is opposite over adjacent. Now, when you set these ratios up, which we will do in a minute, it can help you solve for a missing side or a missing angle in a right triangle, but that's for another time. But what is super important is that your calculator is in degree mode. If it is not in degree mode, all of your calculations will be incorrect. So let's go ahead and start writing some trig ratios. So state the three trig ratios for each triangle for both reference angles. Okay, so I will start with A as my reference angle, and I'm going to label it with reference to A. The 5 is my hypotenuse. It always will be because it's the longest side. If I draw an arrow or a line across from A, I have hit my opposite side, and then the 3 is the adjacent side. So now, when you set up your ratios, the sine, cos, and tan, they are functions, so they have to be attached to an angle. You can't just write sine equals this fraction. So it is sine of my reference angle A is equal to, and now if I think of sine is opposite over hypotenuse. So my opposite side is 4, and my hypotenuse is 5. So 4 over 5 is the ratio for sine. And then I can do cos A. Cos is ka. So if I look at the letters, it's AH. So that's adjacent is on top and the hypotenuse is on the bottom. So 3 over 5. And then finally, tan of angle A, we think of TOA. So that's OA. opposite on top and adjacent on the bottom. So 4/3. And now let's try this again, but this time we're going to relabel and use C as our reference angle. So maybe you want to use a different color or erase your previous markings. Now the hypotenuse is the same, but now opposite to angle C is 3 and adjacent is now 4. So I'm going to use these new labels for my new ratios, and this time I'm going to take sine of angle C. So OH, opposite is 3 and hypotenuse is 5. Now when I do cos, that's ka, AH. So A adjacent is 4 and H hypotenuse is 5. And finally, tan C, TOA, OA, opposite is 3 and adjacent is 4. Making sure you're looking at the right labels, and in this case, it's the red labels. Now, something that you might notice is that for sine and cos, the ratios 4/5, 3/5, or 3/5, 4/5, they're always going to be a value less than 1. And that's because the hypotenuse is always in the denominator. And because the hypotenuse is always the largest side, the larger number will always be in the denominator. So when you do a small number divided by a larger number, it will always be less than 1. However, for tan, it doesn't matter. The value can be greater than 1 when you actually simplify that ratio. All right, let's try the next one. So I will do this example with D as my reference angle. So 13 is my hypotenuse, 5 is opposite to D, and 12 is adjacent. So now sine D, so OH, opposite is 5 and hypotenuse is 13. Cos D is ka, so AH means 12 for adjacent over 13 for hypotenuse. And then tan D, TOA, O is opposite 5 and adjacent is 12. So there are my 3 ratios. Now I want you to pause this video, and now I want you to relabel your triangle with F as your reference angle, and then do all 3 of those ratios. Then come back to the video to check your work. All right, so hopefully your opposite is 12, your adjacent is 5 now, so just a swap in that label, but your hypotenuse is still 13. So for sine, we should have 12/13, cos 5/13, and tan 12/5. If you got that right, wonderful. If you made a mistake somewhere, check to see where you went wrong. It might have just been how you labeled your triangle, or maybe you read SOHCAHTOA incorrectly. All right, let's try this next one. So for this next one, I want you to try it all on your own. So let's start with P. I want you to use P as your reference angle to start. Label your triangle, and then come back to the video to check your labels. So your hypotenuse should be 29, opposite is 21 to P, and 20 is adjacent. So now once again, pause the video and state those 3 ratios, and maybe write SOHCAHTOA nice and clearly so that you get them correctly in the order that you place the numbers. All right, so sine of angle P, make sure it says sine P, not just sine, is equal to opposite over hypotenuse, so that would be 21/29. Cos P is adjacent, 20 over hypotenuse, 29. And tan P is opposite over adjacent, so 21/20. Hopefully you got that correct. If you made a mistake somewhere, make a note of it so you don't do it next time. And now, let's use R as our reference angle. So again, label your triangle, state all the ratios, then come back to check your work on everything. All right, so check the way you labeled. Opposite to R is 20, adjacent is 21, and the hypotenuse has not changed. So sine r is going to be 20 over 29 for opposite over hypotenuse. Cos will be 21 over 29 for ka, and tan will be 20 over 21. All right, let's try our last example. I have given you a triangle ABC, and I told you the 3 dimensions, and I told you where the right angle is. And we're going to state all the trig ratios using angle C as our reference. So before we can do that, we actually have to draw our triangle and label it so that we can get that visual. So just draw any right triangle. Now I know when I label ABC, B has to be the 90 degree, and the rest really don't matter. So I'm going to put A here and C here. So now AB is 15 centimeters, BC is 7 centimeters, and AC is 22 centimeters. And we are using C as the reference. So I want you to pause the video once more and do a final check to see if you understand the ratios. So label your triangle opposite adjacent hypotenuse, then write your 3 trig ratios properly, don't forget about the angle, and follow SOHCAHTOA. Alright, so opposite should be 15, adjacent should be 7, and 22, that longest side, should be the hypotenuse. So your sine ratio, when you do OH, opposite 15 over hypotenuse 22. Cos of C, not just cos equals, is going to be adjacent over hypotenuse, so 7 over 22. And finally, tan of angle C is OA, so opposite 15 over adjacent 7. And those are your 3 primary trigonometric ratios. And later on, we will use these ratios and set them up so that we can solve for missing sides or missing angles in a right triangle. So remember, SOHCAHTOA only applies to a right triangle.